who's not here yet. But I will just introduce him. Jakob is doing research and development at the Library Service Center of the Gemeinsame Bibliothekverbund, Common Library. You know what's it called in English, VZG. Yeah, and he's a long-time member of the SWIP program committee since 2014, and he will present on purpose and properties of the JSKOS data format for knowledge graphs. Now we just need Jakob in the this room. We are ahead of schedule, and he's not here yet. Maybe someone ask in the chat. He commented some minutes ago. Okay. Hi, Jakob. I already introduced you, so can start right on.
Okay. So we're a little bit earlier than expected, but normally we run out of time, so I think that's good. Yeah. So it's a pleasure to present at SWIP conference, and I want to present the result of several years on the JSKOS data format that is used at VZG. And yeah, I first start with an introduction, then give some examples and a broader overview, and in the end, applications and some outlook and comparisons between JSKOS data format and alternatives. First, some terminology. So what is this all about? The format was created to encode classifications, thesauri, ontologies, and similar systems. So the naming differs, but yeah, these can be also they're also known as terminologies, knowledge organization systems, semantic artifacts, concept schemes, knowledge graphs, and so on. Sure, there are differences in detail, but we wanted tools to combine them or to work with all of them, and so we put them all in one bag. So I will refer to them as terminologies or knowledge organization systems. And the details are not relevant at this point in time. So all of these systems share the basic idea to encode things, not strings. So we have identifiers that refer to things and not just a name. And these identifiers should be unique, and it should be possible to look it up. So this is the simple idea of linked open data. We have URIs, and well, only URIs would be only one part of the game. Full terminologies also have labels, at least something to display for human beings, and there are links between these entities, and that's all that makes up a terminology. And in practice, we have a lot of different kind of links and properties and so on. And yeah, all of these we wanted to encode in a data format. So in summary, this resulting format is encodes the SKOS data model. So SKOS is familiar to many of you. It's an RDF ontology to encode terminologies. So it has some basic properties for preferred label, alternative label, and hierarchies. But we also needed to encode mappings and sets of mappings, also known as concordances. And so we had to extend SKOS, or we had to invent something new, and we required a JSON format. So that's why something new had to be done. The format is established infrastructure at VZG, so we use it since several years, and it's yeah, the basic format for all of controlled vocabularies. We also have other legacy systems, but these are more and more mapped to the new infrastructure. And this specification is I just released yesterday a new minor version, so it's like an open source. You need to wait a few years more before 1.0, but nevertheless, it's very major. Over the years, there were more and more requirements, so we had added new fields, but the basic structure is the same since several years. Yeah. The background why we did so, it was this project called Colicon. It started 2013, and that's where the basic core of the format has been defined. So it's more than 10 years. The project was to work with mappings between knowledge organization systems. And the main outcome is the web application named Cocoda. This web application combines terminologies, mappings, and annotations and other information via APIs. So one core property of this application from a technical standpoint, it's a serverless application. So it's all static JavaScript files and HTML, and everything is combined in the browser and the client. So the browser needs to query, for instance, names of label, names of terminologies and mappings via REST APIs. And that's why we had to use JSON anyway, or we use JavaScript. So it's the natural choice is JSON format. And that's one part of the technical background. And the other is we wanted integration of federated systems or federated data. So RDF was a natural choice. But we need something to combine RDF and JSON. And remember, it was 2013. JSON LD already existed since 1 or 2 years, but it was in a very early stage of development. And we concentrated on JSON with URIs first, and that's why we started with something on our own. But the resulting format is not something invented without references. We looked at existing solutions, so basically SKOS for core classes and properties, and JSON LD and other existing ontologies. So if there was some property that could be reused or had been defined in some other ontology, we better use this instead of inventing our own. And most of the fields of this JSKOS data format are mapped to existing ontologies, and we first started with fields that were needed in practice, and then looked whether or how they are used in RDF world, and not the other way around. Another influence is Cosmos API and APIs of other systems that provided access to terminologies, because we wanted to combine access to as many ontologies and terminologies as possible. And so we also defined the API to look up terms and labels and hierarchies and so on. And one of the major influences was Cosmos, and also the JSON format provided by Cosmos. Then the new, more recent influence is the Wikibase data model, because we introduced features similar to Wikibase, and there are a lot of standards built on. So, for instance, annotations for reviewing mappings are just web annotation data model. For geospatial data, we just use GeoJSON or IIIF for media files, and other standards like XML data types. Okay, so as you best learn by example, so I will show the basic or the most relevant features of the format by examples. So here's the JSON for a concept. So it's a concept from a terminology. It's a concept in this case as a class 641 from Dewey Decimal Classification. So it has a notation, this 641, that's a local identifier. But for RDF, we need URI. So there's a URI field for the global identifier. And this JSON record also contains information. This is a concept. So in the type field, you may note this type field is repeatable. So a concept may have additional types, but the basic core type is it's a concept. and it has fields like preferred label known from SKOS format, and this label can be can exist in multiple languages. And because the preferred label is must only be one label per language, this is a requirement, and so in JSON it's easy to enforce if this is encoded by a language map. So the language code are the keys of this map. Yeah. But we wanted to go beyond plain SKOS and also encode mapping. So there's another object type for mapping. There's another type URI, and here the type URI is a property from SKOS mapping properties. And the actual members of the mapping are in this nested structure. There's this field from, then there's the field member set to inside from, because we also support many-to-many mappings, not only one-to-one. So we can't do it with a simple triple, but yeah, the participating elements in the mapping. In this example, it's the class from DDC for food and drink is mapped to food and beverage in Wikidata, and it's roughly the same. Or here, this mapping states it's exactly the same, and we can store a lot of additional metadata, like a justification, why, who created this mapping, was it created manually or by some algorithm, and which tool was used to do so. For instance, here in this example, the tool is referenced as a Cocoda web application, but yeah, there can be a lot of more metadata, and all this metadata for about mappings was not possible to, or was not defined before in SKOS format. Okay, so concept on mappings, and another interesting feature of the format are concept bundles. These are combinations of concepts. In this example, there's a in the DDC classification, there are combined concepts. So there is one class with a very long number, and this class is composed of this core class food and drink we have seen before. So there's one DDC class 641 for food and drink, and then there's an additional attachment. What's called yeah, a table number in DDC, but similar concepts exist in other vocabularies. So you can combine food and drink, and with 6th to 15th century, and you get a new concept that is about medieval cuisine. And this combination of concepts, yeah, can also be used to store the subject indexing of a record. So, for instance, a book could be about both food and drink and medieval times. So it's about, or it could be about medieval cuisine, and it's the difference. How do you combine these concepts? And another feature of this format is concept occurrences. So this is the information. Here we have information about a database with an identifier, and again, this member set field with a set of concepts, and in this case, it's just one concept. So this is the information in this database. There, the DDC class is used for indexing of publications, and we have an count, so a number of 18 publications. And there's a link directly into the catalog. So if you follow this link, you get 18 records about medieval cuisine in this library catalog, and the information about the number of records and the link into the record into the catalog, and the concepts from terminologies can also be encoded in JSKOS format. So these are 4 of this of the object types from JSKOS data format, but there are some more, and so I'll give a broader overview. Summarizing, so we have 2 superclasses. We have an item and resource. So resource can be anything that's similar, like a resource in RDF, and item is a named entity that has also name and some other properties. But these are all mostly used for superclasses. For instance, a database is a resource or an item, because this format is not about databases in particular, but it's more about concept and concept bundles. So this concept bundle superclass I showed with an example. So combination of concepts. Then there are core concepts, and there are concept schemes. I won't show an example now. But a concept scheme is like a whole classification or a whole ontology, so information about a vocabulary. Then there are mappings as shown, and there are concordances, and the concordance is a set of mappings between specific vocabularies, for instance, mappings between RVK classification and DDC classification, or between DDC and Wikidata or other systems. This was the main use case for this Cocoda web application. Then there are occurrences like shown. So when some concept is used in an application for indexing records. And we have object types called registries, distribution, and services. This roughly mapped to a decade ontology. These are used to store the information where something can be queried or download. For instance, whether there is a file to get an OEL file to get an ontology, or whether there's an API to query some terminology via a specific kind of API, like SKOS API. Yeah, so this can also be stored and looked up. And we use this in particular in BARTOC registry to store information about all of these terminologies. Yeah, and there are JSON types for IIIF and GeoJSON and web annotation. So these are included in JSKOS data format, but it's basically a subset of the existing standards. So these are the object types, and each of the object can have a lot of fields. So some common fields like preferred label, alternative label, known from SKOS data format. Then there are a field for identifiers. So often we have the case that we have it that some concept has not only one URI but multiple URIs, because multiple people or organizations drafted identifiers for the same. So either you do a mapping or you store these alternative identifiers in the same record. Yeah, some fields like previous or next, or like start date or end date, are useful for instance, for start date and end date are also used for people. So someone was born at its start date or died at an end date. And so it's a simplification of other ontologies. So this not only for people but also for all kinds of entities. And from practice, fields often asked for is the location, so geographical information, address, or media files, so thumbnails or other kind of images. Yeah, or you can link entities between different versions of something. So say something is a version of another item, and several more. I won't list all of them. I haven't counted the latest draft, but it's all strictly defined, and there's a JSON schema to check the definition of each of these fields. Yeah. And now I want to explain a more a special feature that had been introduced, I think, last year, because it was asked for by users, the users that create or manage terminologies, and they were not comfortable with only these fields or with the existing list of fields. They also wanted to define their own fields, or people came up with more and more fields, and I hesitated to extend the JSKOS format, because the JSKOS format should be some minimal version, and so we needed some extension mechanism, and the extension mechanism is qualified statements. And this screenshot is not from our database, but it's from Wikidata, because Wikidata has something similar, or we aligned with Wikidata and Wikibase data format. So here you can state that something has a country, and the country has two values, Germany and West Germany. And Germany has a start time and a reference, and West Germany has a start time and an end time. So this is about a city that was in West Germany as long as West Germany existed, and after that it now belongs to Germany, and there's also a reference not shown here. And this say first statement, Germany is preferred, and the other one is outdated or it's not preferred. And yeah, this is a part of the data model of Wikidata. Wikidata was created this way to store information that is extendable and could also be outdated. And so we defined in JSKOS a way to encode the same information. So this example stores information about an entity named Göttingen, so my hometown Göttingen, and it has some qualified relations, so links between entities, and the relations have here a URI as field name. So if you don't know about this URI, you can't make use of this information. So it's you can add your own properties as you like, but the structure of the value is defined. So the value here, qualified relation, it's a resource. The resource can have URI and preferred label again. And this statements can be ranked, and there can be a start date and an end date and a reference. This reference here, the field name is source. So this covers an important part of the Wikibase data model, and it came from request by users, and so we ended up with similar result. Or well, I looked at Wikibase, or I knew Wikibase data model before, so it was an obvious choice to do it similar way. Yeah, so these qualified statements are inspired by the Wikibase data model with rankings, references, and arbitrary fields identified by URIs. So in the end, JSKOS format now is a full knowledge graph format. You can encode anything or encode RDF inside of JSKOS, but this does not make much sense because, well, yeah, it could be of use for a lot of things. It gives you a lot of flexibility and extensibility, but at cost of full interoperability. So the basic use case was to agree on or to define some fields that are often used, like preferred label or narrower, broader, previous next, and not to everyone let's use its own ontology, but yeah, extensibility is possible and used still. So these are qualified statements. Then we have another feature that is only used in parts of the applications, and this is about closed word statements. So if some field is not given in a record, for instance, there's no preferred label, then we don't know about. So if something only has an URI, so it may have a label or it may have no label. But we can also give an empty, if the value is repeatable, give an empty array, and this means there is no value. For instance, if you show the narrow, in a hierarchy, the narrow concept, if it's an empty array, then there are no, then it's a leaf concept. There are no narrow concepts. But if we want to show if the data is incomplete, so for instance, if the list, there's a long list of items, hundreds of them, or we only want to show the first 10, then we start in an array and the last value is null. And if by JSON LD rules, null is ignored, so it does not hurt. But the web application can check, there's a null value, so there's more information, so I have to query the API for giving me the next page. So yeah, this semantically, it's all, we have open and closed word assumption in RDF, and JSKOS in some way can combine with both if needed. Okay, so these are the major features of JSKOS, and yeah, I can only advise to have a look at the applications and the standards, because sure, it's a lot of features and often you don't need all of them. So where is this format used? So the main use cases are at VZG at our institutions, and as I said, it's now an infrastructure. So it's in this Cocoda web application to create and manage mappings. It's the internal data model of BARTOC terminology registry, so information about all vocabularies and terminologies we know about. And then we run another terminology service where people can manage their own vocabularies called DANTE, and this is where the extended user requests came from. And yeah, DANTE is an independent, so the code base of DANTE and Cocoda and BARTOC is not shared. So the standard and the format is the same, but the source code is fully different. So this helped a clear specification of the data format helped. So we did not have to agree on one programming language or one system. Another use case that goes beyond our own institution is an NFDI. So we are a member of NFDI for objects and at TS for NFDI, and participate in both with the Cocoda web application and provide information about terminologies. And so the data format and the API is also used more and more in this NFDI consortia or beyond. And yeah, I hope it will get some more attraction and people, if needed, use it in other NFDI consortia as well. So it's slowly being adopted outside of VZG as well. We have 2 or 3 implementations existing or being worked on, I know of, by other people. But yeah, the main use case is our infrastructure for terminologies. If you want to make use of it or put it in your own code or just have a look how it's used in which software application, we have several applications, most of them written in Node, so in JavaScript. So JSKOS server is a database management system to store data, so you can put JSKOS record in there and get it's made sure that it's all connected and valid. Then we have some widgets to display objects, for instance, to get a tree view if you connect it to an API where concept can be queried, then you can browse around with this widget. It's written in Vue.js. Then we have a web application also to browse around in data. This is JSKOS proxies, a bit similar like SKOS, not that, but with less features. And the backend is not triple store, but the backend is a JSKOS API. This is also used in production for terminologies we host. For people can look up the URIs and get a nice HTML view. Yeah, then for programming, we have several JavaScript libraries, JSKOS tools or command line interface to validate and convert data. And we have an API that queries our main library catalog, so you can look up subjects of a record or look up which books are indexed with a given subject given by its URI. And yeah, there's some more, but these are the main applications and libraries. And yeah, JSKOS API is not focused on this talk, but it's also defined. So basically you have REST API above JSKOS data with optional authentication. And yeah, JSKOS API has been implemented by others too to connect to our systems. But I will briefly give some view beyond JSKOS, because often the question arises what's the limitation, why yet another data format? So there are some technical limitations, like labels must have a language tag. In RDF it's not required, but you can use undefined UNG for undefined. Notations don't have data types, or we don't support SKOS collections yet, so technically it's not 100% SKOS compatibility, but haven't had a need to use these features. Then in practice, you often have to think about what is a field about. Is it about the entity or the metadata? So the start date is when a person was born. Created is when the record about the person was created. And yeah, I think the main limitation is there's no standards body behind. So basically, well, one could say it's a one-man show, but there are more than a dozen colleagues have already worked with it, and or other people. it's not only me, but the main standardization is just me. So I agree this is some limitation. So there are alternatives. Yeah, you could use RDF, JSON-LD, or property graphs, but all of these have limitations. So JSKOS can be mapped to RDF, but we need to agree on URIs, or for some fields, we don't know which ontology is best to choose. We need a triple store to access the data within RDF, and then for mappings or other complex data types, we would need to introduce reification, and this is complicated. And RDF-star even adds more complexity. So there, just only RDF is too complex for web application. JSON-LD is the solution. So most of JSKOS is JSON-LD, but it's not normative. So there's a JSON-LD context, and yeah, I can't guarantee that 100% every field can be expressed or is automatically converted to RDF with JSON-LD. You also with JSON-LD you also need a triple store, because there are multiple ways to express the same data in JSON-LD. This could be improved with JSON-LD framing. I haven't had a deeper look into it yet, because it wasn't there when we start with JSKOS format. Yeah, so it's the only way to guarantee a strict JSON format. It's JSON schema, so we provide a JSON schema. Property graphs would be another solution. It's easier to work with than RDF and Sparkle, but it's not for merging data, so there are no URIs, and no standard data format existed for property graphs. So we created one, but yeah, property graphs is another technology. We are more close to RDF. So use JSKOS if we want to access our APIs, our data, or if you process semantic artifacts in JSON. And it's all compatible with RDF, but you don't need the RDF technology stack. Yeah, and just try out and ask if something is missing or if not clear. Thanks.
Okay, thanks, Jakob, for your talk. So you brought us back on schedule, or even behind. Thanks. So there are a few questions. I think you already mentioned that there is a JSON schema available, so please drop the link into the chat. This was one question, and then there are some for the many. One for the many-to-many mappings. Why you would do that? If you could give an example.
Yeah, one-to-many is something could be mapped to a combination of concepts. Like maybe there's medieval cuisine in one terminology, okay, and the other one only has two concepts that must be combined, and so we have member set or member choice, these fields too. But yeah, most of the mappings are one-to-one. We only need to support also one-to-many mapping.
Okay, then there's another question about member lists, but I think that can also be addressed in the chat, because yeah, I would like to even read it out loud here.
It's about the order of concepts. So in RDF, there's no simple ordering, and in JSON we have ordered arrays, and yeah, but technical details.
Okay. Thank you again, Jakob, for your talk, and then we move on to the next talk.